Alright, so what I want to look at today is different kinds of events and events that occur together. And let me just warn you that the concept that we're dealing with here can be a tricky one to really understand. Okay? So make sure that you're really engaging your brains here, okay? Or else you're going to get lost really fast. Understand too that the concepts we're talking about are not opposites. We're going to delve a little bit deeper into mutually exclusive events and independent events, okay? And I remember when I first studied this, I had it in my head that these were somehow opposites. They're not, okay? They're just different concepts here, alright? It's really just different contexts that we're dealing with. Alright, so first of all, mutually exclusive events are events that are impossible to occur simultaneously or occur together. For example, if you flip a coin, it's impossible to get a head and a tail at the same time. Okay? However, if you roll a die, it's possible to get a prime number and an even number at the same time. I could get two. So those would not be mutually exclusive, whereas getting a heads and a tail would be mutually exclusive. Or rolling a die and getting an even number and or an odd number, those would be mutually exclusive. Now, if two things are mutually exclusive, that means the probability of them happening together, this right here, what symbol is that?
Union.
No.
Other one.
Union.
Union, it looks like a U. This is intersection. That means the word and. What's the probability that it's A and B at the same time? It's 0. Okay? Think intersection. Okay? There's no intersection. Right? Now, a Venn diagram is helpful here. I want to look at a case, and let's come up with a couple of sets of numbers. Alright, first of all, what are the prime numbers less than 20?
1.
One.
No,
No.
not 1.
Can't be 1, 2,
2,
3, 5,
5,
7, 11,
11,
13.
17,
19.
19. There we go. Okay? So, then let's look at a set over here. What are the multiples of 8 that are less than 20?
4 and 2.
Multiples of 8, not factors of 8.
16,
8 and 16. Okay? Like I said, let's make sure we're engaging our minds.
I thought you meant
I'm hungry.
I know,
can't
I know.
starving.
Yeah,
Okay.
I'm not fulfilling Maslow's hierarchy of needs right now.
That's Low's hierarchy of needs.
Maslow.
Oh boy.
You don't remember that face with health class.
Alright, anyways. How about multiples of 3? What's the first multiple of 3?
3, 9,
3.
6, 9, 12, 15, 18.
Alright, so there we go. We've got these numbers here. Let's construct a Venn diagram. Okay, are there any numbers that are in all 3 of them?
No.
No. So, this would be the intersection of all 3. It's empty. Okay? So, where do the prime numbers and the multiples of 8 less than 20 intersect?
Nowhere.
Nowhere. Okay? So 8 and 16 both go in here. Okay? Where do the multiples of 3 and the prime numbers intersect?
3.
At 3. Okay? So here we have 2, 5, 7, 11, 13, 17, and 19. Okay? And then we have 3 right there. Here we have the 3, 6, 9, 12, 15, and 18. Okay? So question. Are the prime numbers and the multiples of 3 mutually exclusive?
No.
No.
No, because it's possible to be both if you're at 3. Okay? Are the prime numbers and the multiples of 8 mutually exclusive?
Yes.
Yes. Okay? The intersection of those two sets is empty, so prime numbers and multiples of 8 are mutually exclusive. Okay? How about multiples of 8 and multiples of 3?
Yes.
Yes. Would it be mutually exclusive if we kept going above 20?
The prime numbers and multiples of 8 would always be mutually exclusive, but the multiples of 3 and the multiples of 8 would no longer be mutually exclusive.
That's right, okay? If we kept going above 20, eventually we would get an intersection at 24, and then we could do 48 as well, okay, and we could keep going. But since we stopped it at 20, we would say these are mutually exclusive because, again, their intersection is empty, okay? So prime numbers less than 20 and multiples of 3 less than 20 are not mutually exclusive, but the other two pairs here are, okay? They cannot occur together. Therefore, what's the probability of having a prime number less than 20 and a multiple of 8 less than 20?
0.
0, okay? Alright, so, by the way, there is one number that we didn't deal with. If we're talking about whole numbers or something, if we were doing a Venn diagram, we would put, 0 and 1 outside here because they're not in any of the sets. So, but anyways.
Isn't 0 on one of them though?
How?
No.
It's not a multiple.
It's not a prime number because it's not divisible by 1.
Well,
it is.
by
but
definition, 1 is not a prime number and 0 and negative numbers are not prime. 0 actually is not a prime number because there's actually an infinite number of factors.
Yeah.
0 times 1, 0 times 2, 0 times 3,
Oh.
0 times 4, 0 times 5. So it's not prime. Negative numbers are not prime either because even like a negative 3,
1 and negative.
you have 1 and negative 3, but you also have negative 1 and positive 3. So there's more than one pair of factors. Okay? Anyways, there's our number theory for the day. So let's look at the probability of a union. Okay? Here we're talking about one event or another. Okay? One event or another. And there's a general formula, and then there's a formula specifically for mutually exclusive events. Okay? Let's take a look at this. If I'm finding the probability of A or B, okay, that's a union, or, then I'm going to find the probability of A plus the probability of B minus the probability of both. Okay?
Oh wow.
If they're mutually exclusive, what's the probability of both?
0.
0. So, if they're mutually exclusive, then it's just the probability of A plus the probability of B. Alright, so let's think through a couple of examples. First of all, looking at a couple of events that are not mutually exclusive. Okay, let's say we're picking a card from a deck of cards. What's the probability that the card is either a heart or a face card? Now, those are not mutually exclusive because some of the hearts are face cards, right? So, this is one where having that Venn diagram could be helpful. They made a Venn diagram for us here. And you'll see here are all of the face cards, here are all of the hearts, and the intersection is not empty, so I know they're not mutually exclusive. So if I want to find the probability of a heart or a face card, okay, first of all, I need to figure out what's the probability of a heart.
Isn't that just 13 or 52?
13 out of 52, okay? Which is 1 out of 4. 1 out of every 4 cards in the deck is a heart, okay? Plus, what's the probability that I get a face card?
16, 52.
12.
Aces aren't face cards.
12.
Oh, yeah.
12 out of 52,
12.
okay? 12 out of 52 reduces down to 3 out of 13, okay? Because 3 out of every suit is a face card. But then I need to subtract the intersection, okay? What's the probability that I have a heart and a face card?
3 out of.
3 of 52.
3 out of 52, okay? Now, you'll notice here
Isn't
I have fractions that don't have a common denominator. So, while we recognize that those reduce, it may have been good not to reduce until we get the end. So we'll put that back to 13 out of 52, and the face cards back to 12 out of 52. And that gives us
13, 22.
22 out of 52. Okay? 22 out of 52, which is 11 out of 26. Okay? So there's our probability of getting either a heart or a face card.
Did we divide that by anything? No.
Well, we already divided. Okay? Alright? Any questions?
Why do you like fractions so much?
Yeah, it's
Huh?
so much easier to do it with that.
Yeah. Why?
Not if you don't have a calculator.
Oh wow.
Yeah, what's 11 divided by 26?
Yeah.
Too many.
It's going to be a little less than 50%, because 13 out of 26 would be a half, so
42.3.
42%? Okay,
Yes.
so
Yes.
you can estimate pretty easily. So,
I actually might even. I have a good accent.
There are some.
it's the best I have. So, it works. Okay? Thank you. Here's another case. Where we actually have mutually exclusive events. Okay? Let's say you flip 2 coins at the same time. What's the probability of getting 1 head or getting 2 tails? Okay? Let's think about our sample space first of all. Okay? We could get a head and a tail, or we could get a tail and a head, right?
Yes.
Or we could get 2 heads, or we could get 2 tails. Right? So what's the probability of getting, if we're trying to get
1 out of.
the probability of 1 head or 2
No,
tails,
Isn't it N? 2 tails?
or means union, or I should say union means or. Okay? What's the probability of getting 1 head?
1 and 2.
Yeah. 2 out of the 4 options have. Okay. I should put this underneath. 2 out of the 4 options have 1 head in them. Okay? What's the probability of getting 2 tails?
1 and 4.
That's 1 out of 4. Okay? So, what's our probability of getting 1 head or 2 tails?
3/4.
3/4. Okay? Notice these are mutually exclusive. So I don't need to try to think of what is the probability of this and this.
So
Okay? Because it's 0.
and we don't need to hold it.
Okay?
Yes.
Yeah, we will.
Oh wow.
We don't have.
Alright.
3号是这样。
I'm gonna skip independent and deal with our last concept here real quickly because it's actually a very, very simple concept that we have enough time for. All right, the complement principle, okay? Since the sample space contains all the possible events in an experiment, the probabilities of each of them occurring has to end up being 100%, because that's everything that could happen. So what's the probability of something happening? It's 100%, okay?
Only prediction is always.
Yes. Now, some notation here. If A is one of the events, then you'll see this notation A prime. That is what's known as the complement. And that's talking about everything that is not A, okay? So when you see this notation, A prime, you need to think not A. Alright, guys, quit talking, please. Alright? So
what's the
here's our probability of a complement, okay? If we know the probability of something happening, we can figure out the probability of that not happening by subtracting it from 100%, okay? It seems like a very simple concept, and it is, but recognizing when to use it sometimes can be a challenge. Let's take, for example, let's say a drug meant to cure an infection has a probability of working, P of W, 87% of the time.
13.
Okay? So what's PW prime?
13.
It's 13%. Okay? The probability that it won't work is 13%. That's a pretty easy one. Let's think about this one though. What's the probability of rolling 2 dice and getting a sum of at least 4? Okay? Well, think about this. If you do it just how it's written, you're going to have to figure out the probability of adding up to 4, 5, 6, 7, 8, 9, 10, 11, and 12. 9 different probabilities you're going to have to add together. Or, what's the complement of at least 4?
2 and 3.
2 or 3. You could do 1 minus the probability of 2 or 3.
And there's like 1 chance of getting 2.
Yeah, that's 1 out of 2, that's
2.
2 out of, that's 1 out of 36 and 2 out of 36, so minus 3 out of 36. That's 3 out of 36, or 1 in 12.
We did good, guys.
Okay? So,
We did
pretty
good,
simple.
guys, but next year we'll do
No, not,
No,
it's 33.
So it's 3.
There we go.
Yeah.